Okay, so I'm going to do maybe one or two Lewis dot structures. Let's do something like NO3 minus 1. Okay, that's our ion in there. And so we'll start off with this structure. Nitrogen's our central. How do I know? Because it forms 3 bonds. And I will start off and I'll count the total number of valence electrons. Nitrogen has 5. Oxygen has 6, and there's 3 of them, so it's a total 18. And the electron, there's an extra electron because it's minus, so that's 1, so that's 24 electrons. So I will put 6 on each oxygen, that's 18, and 2, 4, 6 around the nitrogens, that's 24 electrons total. So now we'll start to look at this and notice some problems. This oxygen has a minus 1 formal charge. Oxygen normally has 6 electrons. So the formal charge, I'm going to write it out, formal is equal to 6 electrons minus, remember how we do it, 2, 4, 6, and 1 for the bond, minus 7 is equal to minus 1 charge. Now I got to erase. So there's my minus 1 charge, and I rapidly recognize each oxygen's the same. So I've got minus 3, and the nitrogen normally has 3 bonds, and it does in this type, but it's violating the octet rule, so I'm going to check that. And then the nitrogen has typically 5, and in bonding it has 3 electrons, 1 for each bond, so it has a plus 2. So here's some serious issues with this one. Well, our total number of electrons are correct, and to really get a Lewis dot structure I'd have to put a minus 1 charge in here, and it adds up, the formal charges add up to minus 1. What I have is I have a violation of an octet rule, which is not always a problem. There's less than 8, but I also have a huge amount of formal charge. So this one is not a good resonance structure. We would not accept this. Alright, let me do another one. So here I have the same basic structure, but this time I'm going to move an electron pair in there, and that is going to give me this structure. Let me carefully erase. I'll have a double bond in here. So now if I look at it, this oxygen here is going to have a formal charge of 0. That's nice, because oxygen normally has 6 electrons, and we have 2, 4, and 1 for each bond, 5, 6. So 6 minus 6 is 0. We've already counted these. These are minus 1. This oxygen is minus 1. And what about our nitrogen? The nitrogen typically has 5 valence electrons, and in here it has 2 for these. 1, 2, 3, 4. So minus 4 is equal to plus 1. So now our total charge adds up to minus 1, and we have a lot less formal charge. Let me redraw this so I get rid of the mess. Okay, so there it is. I have the nitrogen surrounded by the 3 oxygens. I could have several resonance structures of this. I could have an N, double bond O on this side. Notice I'm moving electrons, I'm not moving atoms. Minus 1, minus 1. So both of these, and there are other resonance structures that we could deal with. So these are 2 good resonance structures on here. I'll do a third resonance structure on this that's no good, another example of a no good one. So let me erase. Okay, so we'll take nitrogen, oxygen, oxygen, and an oxygen, and I'll put a double bond here like we had it, and I'm going to take 2 of my 6 electrons here and move them down in here, so I end up with this. So now this looks pretty good. I still got the right number of electrons. I got 24 electrons if you count them all up. I have a minus 1 charge on this oxygen, and nitrogen normally has 5 valence electrons, and now I have 1, 2, 3, 4, 5. Remember, 1 electron for each bond, so that's 0. So I've made my charge smaller. What's the problem with this? The problem is I'm violating the octet rule by going over 8. Nitrogen now has a total of 8 electrons. So there's 2 different ways of counting. One to count for valence electrons, and one for count the total number of electrons on there. There's different ways of counting the same thing. So this structure is not going to work.